What the name of the session's called? Hold on a second. Don't bug me. Yeah, it's double angle. Half angle. And product is sum. Go ahead and jump into the examples. I hope you have those formulas ready, but I'll write them down again as we go. So if cosine x is equal to -2/3 and x is in quadrant 3, find cosine 2x and sine 2x.
What is that same? Oh,
Double
half
angle,
angle.
yeah, double angle, half angle, product sum. Forgive me, a little tired there. Okay. So cosine double angle has 3 different forms, if you remember. Sine 2x has only one. So I'm going to write those down first. This is the 2 sine x cosine x. Cosine 2x has this one here, cosine squared x minus sine squared x equal to 2 cosine squared x minus 1. 1 minus 2 sine squared. So one of these are fine. We can use any of them. Who cares? Now, they gave us cosine, right? So technically, you could use the second one and just get the answer right away. But on sine 2x, you're going to need cosine, which was given, and the sine. So either way, you're going to have to find sine. So let's do that next. So build your triangle. I don't know what sine is. Cosine is this. So adjacent, the quadrant 3, both are negative, right? Sine and cosine. So when we find the y value, or the opposite side, should be negative. Adjacent will be negative. Hypotenuse is never negative. Okay. So solve for the missing side. You're going to end up getting, well, let's go ahead and do it. So solve for b, that will be 9 minus 4. B will equal plus or minus the square root of 5. When you square root both sides, you have to tack on the plus or minus. So this is when you need to decide, do I choose the plus or the negative, right? Because we are in quadrant 3, we choose the negative. This was given, this is given to us.
Oh,
Yeah, they have to give you some information.
So we took the negative to.
I chose this one. So in this section, you're going to have to check, okay, where the heck is this x we're talking about? because that will determine the signs of these. And if you forget, make sure you put it correctly over here. Right? You need to remember, oh yeah, cosine is negative, sine is negative. That makes sense.
Are those all formulas, the sine 2x equals?
Yeah, these are formulas. I wrote them again just in case you don't have them memorized or handy. Okay. So now we can answer the question, right? I'll just go ahead and write them on the bottom. Sine 2x is equal to 2 sine cosine. So that answer will be 2 times the sine times the cosine. So that will be positive 4 root 5 over 9. Now the double angle cosine. Doesn't matter which one you choose. I'm going to choose first one, I guess. I don't know. So that will be this guy squared minus square root of this guy, and that'll give us a 4/9. And this will give us a 5/9. You'll square the square root and 3. 4 minus 5 is a negative 1/9. So there is the two answers they wanted. Is there any questions about the steps? It's okay. All right. Let's do a proof. That's cool on this page. Let me know if something doesn't make sense. Are you gonna do one more of these? Yeah. Okay, you do that. Let me find one for you.
Yeah.
Oh, 7.3, that's what. I can't find it. All right, so these are coming, these types of problems are for the first few, 3 through 10, or stuff like this on your homework. So let's do 4, I guess, from your homework. Okay, so it says find cosine. Find, actually all three, find sine, cosine, and tangent of 2x. Given tangent x is equal to -4/3, and x is in quadrant 2. There. Already? So let's build the triangle first. Do it over here. Tangent x is equal to opposites over adjacent. Now, in quadrant 2, what's negative and what's positive? X is negative, so that negative should be on the 4. Oh, I'm sorry. 3. Because this will belong to the cosine. So do like Pythagorean theorem, and you should get a 5 here. Okay. So using that triangle, we know that sine x is equal to 4/5. Sine is positive, cosine is negative 3/5. And then tangent, we were given as -4/3. That should be enough to still answer the question. So let's do sine first. That's going to be equal to 2 sine cosine. Right? So plug in the sine and cosine. That will give us what? 24 over 25, right? Okay. Now cosine 2x. Formula was cosine squared minus sine squared, right? So that will be -3/5 squared minus 4/5 squared. So that would be 9 minus 16. Nine minus 16 is, what is that? 5? 7? Okay. Yeah. Okay, so we got 2 answers. Tangent of 2x is equal to, I don't remember. Let me look up that formula. Oh, here it is. It'll be 2 tan over 1 minus tan squared. Just plug in tangent and technically done, but we may have to do some algebra. So that will be 2 times -4/3 over 1 minus -4/3 so that will be -8/3 over 1 minus 16/9. Do some fraction work. The bottom will become -7/9. Yes, sorry. Yeah.
The two doesn't affect the between the 3 and the -4/3.
Only if it was 2/2. If it's just one big 2 like that, it's implied that there's a 1 at the bottom. Positive, actually, yeah, +7/24. Yeah. Anyway. I don't want to waste too much time on fractions, but you gotta see how this works, right? You find the 3 pieces, sine, cosine, tangent, and you plug them into the formula. That's all we did. Everything else is just algebra or fractions. The main concept makes sense?
How'd you get 7 back?
7. Get the common denominator at the bottom. This would be 9/9. 9 minus 16 should be -7. So the work I didn't show. That's what happened. Uh, oh, the other way. I mean, that was the top. I showed you the top.
I don't see the bottom line. The little example you showed,
Yeah, sure.
I can't see it.
Oh, what the? Interesting. I thought you were messing with the person. Idea's perspective is off. Zoom. But sure, let me move it for you for now. I'll fix this.
Thank you.
Going good.
Yeah, I think you can do the thing I built that.
It's better, right? Sorry, guys. I didn't know that. Any other questions on this problem? Yeah, as you can see, sometimes the fractions get a little ugly, but the main idea is, if you got to here, I mean, I'd give you probably most of the points, maybe not all of them, but at least it shows me you know what how this works, you know the concept. Okay. Anyway, you guys cool on this page? do a proof now. Show that this is equal to 4 cosine minus secant. So this is the test question. Where would you start?
Did you say start with a fraction?
Yeah, fraction is a good hand, but the big giveaway is the 3x. Like, because this is hard to create, so you should try to reduce that. Like, if you start here, I'm not saying it's wrong, but how do you turn this one into a 3x? Like, that would be hard. It can be done, but it's hard. So start this way. So whenever you see a multiple angle or a sum or something, start over here. Okay. Okay. So change this to, on purpose, 2x plus x inside. So now that you have a sum of angles, right? So apply the sum. So I purposely made an A and a B. So whenever you see like a 3x or bigger, try to break it down into something that you know. Because we know we have 2x formulas, right? Double angles. That's why I did this. That's the logic. So first, apply the sum of angles formula. So we're going to get, formula was sine, cosine, cosine, sine. So sine of 2x cosine x plus cosine 2x sine x. So I applied the sum. The bottom is still sine x cosine x. So from here to here, we did the sum formula. Double check what the name of that formula is. Sum of angles. Yeah, they didn't call it sum. You guys see how we got there? Or is that okay? All right. So now notice we got double angles, right? So we're probably going to use those to our advantage. But first I'm thinking maybe I can put, so notice that we have a minus, right? So I need to create two terms on purpose. So I'm thinking put this one over that one and then this one over that. That way I have two separate things to work on and then hopefully they turn into cosine and secant. Okay. That idea makes sense? Okay, so now I'm here. So at this point, you can cancel stuff. Notice you got cosines and sines right here. All I did was separate fraction. So now I have sine 2x over sine plus cosine 2x. What did I cancel that one? That's my mistake. Okay. I'm wondering if I think there was a shorter route I could have taken. But that's life, right? Okay, so we'll just deal with it. 2 sine x cosine x. Double angle will be, we'll use the, what did we use last time? Cosine minus sine. Yeah. Cosine squared x minus sine squared x will replace the double angle for cosine. From here to here, actually, that other one might be better. Check this out. This one might be better. They might cancel the cosine. So I'm not saying it's you should do that. I'm just trying to think what is the best approach. Should we stick with this one? Sometimes one is better than the other. But I had a thought that maybe having just cosine on top might be better for this reduction. But I'm going to stick with it. It's fine. Do we apply the double angle for both? Okay. This cancels, giving me 2 cosine. Right? Okay, well, that looks nicer at least. I need a 4 though, don't I? Don't have a 4. So maybe it'll come from here. Maybe. What is sine squared equal to in your Pythagorean formulas? Whenever you see a square, you should think, okay, maybe I can use this. Yeah, so we have 1 minus cosine, right? See, I'm just trying stuff, hoping for the best. And there's not just one route. Okay. This will become cosine x squared minus 1 plus cosine. That looks promising. So that will give us 2 cosine x plus 2 cosine squared x minus 1. You see how I ended up with that formula anyway? This should be familiar. You see how I would have saved time if I used the other one, that one instead of this one. Remember how I mentioned it? So that would have saved me 3 steps. But, oh well. Yes?
How did you get plus in the sign?
Oh, we have a minus in front of the sign. So this entire thing is being substituted by a Pythagorean, 1 minus cosine squared. So distribute the negative to both. So minus minus 1 minus. That makes sense or no?
I understand how the negative one, yeah, not plus.
Oh, so picture there being a negative 1 here. So negative 1 times 1 and then negative 1 times negative cosine. So that's why they switch. So whenever you have parentheses and a minus, swap all your signs when you take the parentheses off. Okay, so at this point, running out of space, it'll be plus 2 cosine squared over cosine minus 1 over cosine. Looks like we almost got it. Sadly, I'm out of space because of that nonsense. So,
Oh, never mind, yeah, I got it.
I'll wait a bit. Turn the page. I think a shorter route would have been to apply the identity at the beginning, the double angles, and then see you can separate. So separate at the end would have been better, but I didn't know that until I started working on it. Yes, cool on this page. So we got 2 cosine. You rewrite that last line here. 2 cosine x plus 2 cosine squared x over cosine. Is it minus 1 over cosine? So right away you should see that this becomes just a 2 cosine, right? Plus 2 cosine. And this right here is a secant, which is what we need. The reciprocal identity right there. And 2 plus 2 is 4. Cool. We're done. Any questions on this problem?
So it's probably a pretty good rule of thumb to just every time you have a really long fraction, that way split it up, yeah, the opportunity.
Yeah, I would first try factoring before the split.
Yeah.
But if you see things might cancel, split it and then keep going. Sometimes you might have to recombine them at the end because the split wasn't coupled. So that's when you know, like, oh, should have left them. I should have left them together. But there's no way of knowing until you're working on it. Like, what is the best approach? I mean, that comes from experience. So without experience, you just got to try things and get there. Okay. Don't just freeze up and stare at it. You're gonna have a bunch of these on your test, right? So more than half. Okay, there's also some stuff about power reducing in your homework. Is that a question? I think it's for the added one, right? Use power reducing formulas to express the following. As a cosine function, the power of 1. So basically what we're going to do is remove all the powers using that formula. I'm probably not going to test you on this, but it will be in your homework. And it's not useful until calculus 2. So if you're not going that far, oh well. But that's the only time I've used the higher level equations. So reduce this guy. So here are the formulas, power reducing. 1 minus cosine 2x over 2. Sine cosine squared. Oops. I'm pretty sure I already gave them to you, but just so we have it in front of us, here it is. So what you're going to do is replace both of them with these two. So you're going to reduce the power from squares to those. You're going to get 1 minus cosine 2x for the sine times 1 plus cosine 2x. So this time multiply, and if you end up with another square, which we will, use power reducing again. So you guys cool up to this point? All right. These are conjugates, right? Do you see how this is a plus b, a minus b, a plus b? So you don't have to FOIL. If you want to, you can. You'll end up with this when you do. 2 sine 2 is 4. The top part multiply gives me this. If you don't see it, FOIL it out. Multiply everything. You'll get this. I recommend you use the formula of difference of squares to avoid the FOIL or the product, whatever you want to call it. I mean, I think in high school they use a box method now or something, right? I don't know. But I don't know what that is, but if you want to use that, it's fine. I don't care what you use. Just as long as you get the, as long as your math's legit, you're fine. But notice we have another square. So apply the formula again. What I'm going to do is factor the 1/4 out because I don't want to deal with the fraction right now. Just leave it out there. So I have 1 minus, so on the cosine squared 2x, this top part, apply the double angle again. So that will be 1 plus cosine 4x that makes sense, right? Each time you reduce the power, you're doubling the angle. So look what happened to the cosine squared. We got a 2x. We did it again, 4x. At that point, we've removed all the powers. What was the goal? Power of 1. These are all single powers. It does look ugly though. The rest is algebra. Yeah.
So then what the denominator?
It's from the formula up here. So whatever this is, we'll have a 2 underneath. And actually, I forgot the 2 right there. Yeah, messed that up. 2x. Not squared x. It looked like a square. I don't know. All right. right, so multiply the 1/4 in. Add those fractions together. That will be 2. That will give us 2 plus 1 plus cosine 4x. I showed extra steps so you can see. Final answer will be this. Any questions about this 2? So I need to get the common denominator. I need a 2. Multiply top and bottom by 2 gets me the 8. Now I can add them. 2 plus 1 is 3. We'll just do one of those. I'm not going to really focus on it, but that's what power reducing does for you. It'll keep reducing the powers and simplify the problem. So if you're doing like an integral question in Cal 2, this would be easier to deal with than this. And that's why we would use it, obviously. Let's switch gears. Now let's do a half angle problem. Because earlier we did a double angle. Now let's do a half angle. That's cool on this page. Oh, wait a bit. Example 5. You guys cool on board? You see what the point was? How it worked? So find x over 2, sine x over 2, and cosine x over 2. Given cosecant x is equal to 3, and x, x is between 90 degrees and 180. What quadrant is that for x? Yes, quadrant 2, right? Now, they're talking about x over 2 over here. So if I divide everything by 2, we can figure out where the half angle's at, right? Now where's x over 2? Where's the half angle at? Two for the first original x. 45 to 90 is the first one, right? Okay. So we need all that information to use the appropriate formula. So they want us to find x over 2. That is equal to plus or minus the square root of 1 minus cosine over 2. Cosine is x over 2. That'd be plus or minus 1 plus cosine over 2. So since this is in quadrant 1, is sine cosine positive or negative there? So because of that, we choose the positive version of the formula. So the positive is chosen because of the location of x over 2. Does that make sense? So if x over 2 ended up being in quadrant 3, they would both be negative. So when you apply the formula, you'd be using the minus version. If it was in quadrant 2, then you would be using positive for sine, negative for cosine. See how it matters. Okay, we still need cosine, right? We're giving cosine. So build your triangle, we'll do it over here, I guess. What is cosecant in terms of triangles?
So we're out.
Yeah, so you 1, right? Okay. Find the missing piece. So b would be 9 minus 1. So b is equal to plus or minus the square root of 8, which is plus or minus square root 2, or 2 square root 2, when you reduce the 8. Now, do I pick plus or minus?
Because we're looking for.
And now we're looking at the x. Yeah. In quadrant 2, yeah, we choose minus. So be careful. Don't mess up the sign. It's important now. Yes. We choose minus because of eventually this will be the adjacent side, right? Which refers to cosine. And cosine is negative in quadrant 2. So this has to be negative because the hypotenuse is never negative. So you can think of this as your y value and your x value. So this is negative 2 root 2. So now we can answer the question. Let's scratch over here. Sine x is equal to, I don't think I need it actually. I just need cosine. Cosine is equal to negative 2 root 2 over 2. So sine of x over 2 is equal to positive 1 minus, plug in that 2 root 2 negative over 2. Same thing for cosine. It'll be 1 plus a negative.
Where did you get to for cosine x in the denominator?
That should be 3, right? Is that what you're asking?
The cosine x.
Oh, here, yeah, it should also be 3.
Oh, okay.
Yeah, I messed it up here and then copied it. So at that point, we've answered the question, right? We gave what they wanted, it's just not pretty. It's like an unassembled gift, I guess. Okay, so do the fraction steps. LCD is 3. So make this into a 3 over 3, combine these. This will be 3 over 3 minus, plus, minus, 2 root 2 over 3 over 2. If you divide by 2, that's the same as multiplying by 1/2. This will become 2 sixths. So the final answer would be 3 plus 2 root 2 over 6. Gotta skip a couple of fraction steps. Okay. You follow me from here to here? Right, we have to get the common denominator on top. 3 over 3. So then you can add these together, but this 2 is the same as having a 1/2 in front. So that would become a 6. This is the exact same thing, except there is a plus. So the answer should be same. Should be a 3. Okay. But what really matters, right? Can you choose the right signs for the formulas? Do you see how we figured out what quadrant the half angle was in? Right, that's the new stuff. Fraction stuff, that's whatever. Does it make sense though, the concept?
Where did we get the 1 minus? Where did we get the 1 minus? First step, under sine x over 2 equals the square root of 1 minus. Where did we get 1 minus?
Oh, this one?
Okay, so that comes from.
So these
okay,
are
so that
these are the
comes from
formulas.
that equation.
Yeah, we're applying the form because they asked for that, right? They asked for sine over x over 2, cosine x over 2. So we apply the half angle formulas. We needed the cosine to do so. So I just found the cosine over here, wrote it down there, and plugged it into the formulas. That's all we did. But you just got to be careful that you choose the correct sign on your formulas. Okay. Once you plug it in, you may need to add fractions. You get to get past fraction thing, especially if you're going further in math. Time to get over that. Should just give you a test, nothing but fractions. Okay, I'm kidding. Anyway, you guys cool number 4? Any other details bothering you? I know it looks natural, but don't let it bother you. Okay. give you one more example, and let me see if we have time for some practice stuff. So this is similar to stuff we've already done. It's just a little different. This is number 5, right? 6. To simplify the expression, involving an inverse. So you guys remember, I think you had one of these on your test. It was like tangent, sine inverse, right? Do you remember that? So we're gonna do the exact same thing, but now it'll be a double angle side. Okay. So the work will be the same. This is your question.
Is that involved with the inverse?
Yes, involving an inverse. The sine of cosine, 2 cosine inverse x. So they want us to simplify this like we did these. So if these make sense, then this will be no problem. If you don't know how to do this, then this will be difficult. Okay. So first step, just like we did before, we said let theta be equal to the inverse piece. So nothing has changed. The approach is the same. Then we said by definition or by some algebra, this will become cosine theta equal to x. Okay. And then we would build a triangle, right? Here, we're not going to worry about signs or anything like that, like what's negative, plus or minus.
So I noticed you chose cosine theta as opposed to sine theta.
So we choose the inside part. So whatever is inverse, we have to rename it,
Okay.
and then we apply the inverse definition, and then we build a triangle around this, just like we did these problems. We would build a triangle by based off the sine inverse, and then find out tangent was. So what we're going to end up doing is finding out what sine 2 theta is, right? So actually, let me go ahead. Show an extra step. Essentially, what we are doing is substituting that theta here to get sine of 2 theta. That makes sense? Once we get there, apply your formula. So that'll be 2 sine cosine, the double angle identity. So we need sine and cosine. Sine is equal to opposite over hypotenuse. Cosine is x, technically, x over 1. So just plug that in and you're done. You have 2 times that square root thing times the x. That's your answer. You can make it pretty if you want.
Repeat the square root of 1 minus x squared.
You'd have to solve for this doing the Pythagorean theorem. So when you, this is like the a, solve for a, and then it'll come right up.
Show us how you got that.
Which one? Yeah, sure. So we have a squared plus b squared equals c squared. We were only given these two pieces, right?
Right.
So x squared plus b squared equals 1 squared. Solve for b, or I said a, but whatever. Same thing, same thing. These sides can be interchangeable. The only one that can't be is a hypotenuse. So b squared is equal to 1 minus x squared. So b is equal to plus or minus square root. But as I said earlier, we don't really care about the plus or minus because they're not telling us where x is. So this is general x. Fine. Or side scratch word. Okay. I think we'll have to stop here. So on Monday, we'll do 7-4. And Wednesday, we'll probably do 7-5. I don't think we can do both. 7-5 is kind of long. That's it. Start to review.
What homework for today?
Oh, I already posted it, but here it is. This one's due Wednesday. Give you some extra time.
We have nothing today, right?
Yes. The one from like over a week ago, I'm assuming that one's already done, right? Just uploaded by tomorrow, or today, sorry. Seven point. Homework is 5 through 49 odd. And your exam should be ready by Monday. I've already finished the other class. 90% sure it'll be done Monday. Something weird happened over the weekend.